The application our group has decided to create is a simulated grocery store system. You can see here we have the different functionalities split across the different forms and pages. So we have the customer creating new customer page, the restocking of products, advanced search options, which takes in our data and searches the database using correlated nested queries and other stuff. Searching through different products like meat, home supplies, produce, and of course admin functionalities, which allow the admin to add products into the database. The target users of this application are of course people who enjoy shopping for groceries from their home. A regular non-admin user can create an account, browse products, utilize advanced search options to sift through the large number of products in their grocery store database, and add products to their cart as well as purchase products. Admin users who are employees of the grocery store can have functionalities to update the stock, create new customer users, and insert new products into the database.
Some functionalities that are included in our grocery store app include select queries, in which in the meat section, the home supplies section, the produce section, we select the correct type of products and display them on the screen, as you can see. Besides select queries, we also have other abilities such as adding a new customer. So we are able to create a customer, adding a name and a customer ID in order for use later on for adding a cart. When adding to cart, we will use a customer ID, a customer cart ID, and we'll be able to pick the product that we want to add to the cart. This is not only creating a new customer and cart, but if the customer ID already exists and the cart ID already exists, we are updating the price on that said cart. Another feature we have is the ability to add a new product. So, for example, in meat, we will be adding the product name. We need to add the meat type. We need to add the sell by date, price, and a company name. And finally, we have an admin restock section in which we are able to restock said products. So for our example here, we have a test product, and the amount we have on there is currently 10 on our stock. So the way our restock product, instead of putting the amount number we want to add more, we put the amount number we want to have in total. So in this case, I want to increase 10 by 20, and so I add 30 so we can have a total of 30.
Simply click on the advanced search options button. Okay, so here we are. These advanced select queries utilize SQL functions such as aggregation, group by, and the having clause. And we also have a correlated nested query implemented here for this third button. So let's say I wanted to search for companies by product count on the store, and I wanted to limit how much I wanted to see at a time. So we'll simply put in, let's say I want to see 5 products at a time. We'll put in 5, and then that'll be our user input, and we'll click the button right here. And as you can see here, it shows us 5 items. So now let's say I wanted to search for products of a certain price, which of course a lot of grocery stores use. So we'll put in, let's say $1.99 for our user input. So we put that in, and we click the button. It shows us everything that's $1.99 and less. So let's search for another price. Let's say 172. We put in 172 and we click the button. And it shows us the product count for everything.
Alright, and finally I'll be going over our interesting aspect that we've added to our project, which is an unclustered index to improve the performance of our search functions within our program. So right here, here's our database, and the unclustered indexes we're going to be creating are going to be on the home supplies, the meat, and the produce tables. So here's the meat table right here for reference. Right now, there's no specific ordering to any of the tuples. It's not ordered by name, price, sell by date, or meat type. So when we go to our program, and when our program runs, it'll call these 3 queries. The first one on the meat table, creating an index of m type on these 3 parameters. The second one on the produce table, with an index called sell date. And then finally on the home supplies table with an index on price. So when our program gets run, which is right here, and we go back to our databases, and we refresh them, we can see that now our unclustered indexes are now added to our database. And the way this improves it is that if we look at the table here now, that all of the meat table is now grouped and ordered by its meat type. So the benefit of this performance-wise is that in the event that our database or our meat table ends up reaching to 1,000 to close to 100,000 of tuples, that any search query done on the meat type, so say you query for all the chickens, will end up being much faster than it was before when the ordering was of no specific order.